Hello. Thank you very much for coming to my talk today. I'm flattered that there's so many seats taken. I was expecting something different, so thank you for that. My talk today is about a history over the last 9 years in our organization, Flixbus. And it's about a modernization journey and what we've learned on our way. And let me dive right in. So I want to give you a quick outlook first of what we're going to talk about today. I'm going to give you a small history tour, right, to understand the context that we've been in before we started on this kind of modernization journey. And then I'm going to talk about what the actual problem was that drove us to the decision to embark on such a journey. Because it's important to know that not all the reasons are valid. Then what can we do about that very problem? That's going to be the next point. And then we're going to talk about the 5-step improvement process that we have discovered worked very well for us. And of course, I hope it can work for you, but I know that each organizational context is different, so maybe for you it would be a 6-step or 7-step or 4-step process. Who knows? And if we have time, maybe a little bit of Q&A, but if we don't, you can still catch me afterwards, ask me questions. I'm a very nice guy. I'll try answer any question you have, so just grab me afterwards. So let's start with a small history tour. And that's a little bit, what is the evolution of the code base? So we had a monolith, and you can see the numbers here, right? So we started like in 2012. The market was liberalized in 2013, the German bus market. So we started development in 2012 already. The tech stack was a classic web development stack of the time, PHP 5.2, a MySQL instance in version 5.5, and jQuery 1.8. Is anybody still using jQuery here? I'm 1, 2, 3. Don't be shy. So in 2015, we merged with our largest competitor on the German market, which was Flixbus, because the brand I started working with was called Fernbus, so these were the two major competitors. And we decided to merge because it just makes more sense instead of fighting each other, dumping the prices, that you merge and, try to be a bit more revenue generating oriented instead of fighting each other. And in mid-2017, we understood that something went wrong, or even some things went wrong. And that's when we started our journey. So we started with 170,000 lines of code, very, very small application, and only 12 people working on the code, to 2018, where we had 175 people working on the actual code and 11.2 millions of logical lines of code. So let's talk about the architecture. So this is a title of the IEEE Computer Magazine. No silver bullet, right? That's the classic Fred Brooks article in which he describes it. I love the cover, by the way. It seems like some wolf is just gonna jump out the bushes and ambush that woman. She already knows what's coming. But somehow we as an industry are very good in consistently and repeatedly coming up with new silver bullets, even though we know about this. Because it's not a technical problem, it's a social problem. We haven't solved that yet. But it's the same, it was the same for us, right? So Jeopardy time. So it's a little quiz. So who hasn't played Jeopardy before, there's a statement and you need to come up with the question, right? So this architecture pattern was the most widely used software and framework architecture for web-based projects in 2012. So who wants to solve it? What? Yeah, part of it. More specific. Anybody? MVC? Who said it? There. Applause for that man. It's correct. The classic model view controller architecture. So I have to say, nothing is inherently bad about that architecture. It's not about the architecture. I want to, make that clear, because it's about how about you use it, not the architecture itself. You can build very nice applications with the MVC architecture. But the frameworks back in that days made it very easy to make very, very bad mistakes. So who doesn't know about it, that's how it works. You have a model, which is like a representation of your database schema that is, delivered to the users of your application through a view. The user, does something, and the controller receives data, manipulates the model, and it goes back into the database, right? That's it. It's a kind of layered architecture. And for us, it was a good choice. It was fast to get started, right? As I said, there was a deadline looming. The liberalization of the market was beginning of 2013. So, there's a hard deadline. You need to go fast. Like, there's a promise that, you can change all these layers independently, right? So you can change the front end independently from the controllers and independently from the models. So that sounded like a really great idea back then, right? You have the ability to provide multiple views. You can build an HTML site. You can build CSV downloads. You can build a REST API, right? So you are very, very flexible within that single application to deliver any kind of use cases. And normally these MVC frameworks, they came with batteries included, like routing, security, templating, all of this was there. You didn't have to reinvent the wheel. You could just use what the framework provided and focused on, the features. Yeah, but Houston, we have a problem. It went very well. We were very successful. We were growing a lot. We were making a lot of money. And that's a curse of successful applications. Because they grow so fast, there's often a point where you miss changing the way you build software. Going from this, like Facebook said, going fast and break things towards going slower and don't break as many things as before. But what was our problem? Because it should be a business problem and not a technical problem. Often I speak to people, yeah, but on the database we have so much contention and these are the technical problems. It's not a technical problem. The organization doesn't care if there's a technical problem. The organization does care if, when we don't deliver value, that a competitor is gaining an advantage for us, or that we're losing customers, or that we're losing money, right? That's what the business is caring about. They don't care about, database migrations going wrong, or this code is so messy, I don't want to, work with it anymore. That's not really a reason. So we need to focus on a business reason. And this is basically the one metric that I normally use to communicate that. It's the classic lead time, cycle time, reaction time. And what we discovered was that, the cycle time kept increasing more and more. What the cycle time is actually development time, right? So developers working on the code. The reaction time is some business analyst has an idea, and they discuss it, there's some discovery, and then, okay, let's build this. So that's the reaction time. There can be a lot of problems with reaction time as well. I'm not saying but the cycle time, if that is increasing, then there is something in the technical side of things, right? So it's not in the organization. The idea is there, the feature is there. Please build it, but it takes longer and longer. And for us, it kept increasing up to the point where we were not able to actually deliver features, where we had to say, that's currently not possible, I'm sorry, like, we would have to change half of the system to actually make that happen. So if you have to say that to the people in the organization, that's a strong sign that things are going very wrong and that we need to change something. And that was also the case for us, right? So we took that signal and started to do something. But before I talk about, how we approached solving the problem, I want to dive first into the failure patterns, right? So what actually went wrong on the technical side? Because, as I said, it was not the architecture itself. It was not MVC. MVC is innocent. We are the bad guys. So the first failure pattern is anemic domain models. The frameworks back then made it very easy to build these models. There was like a command on the CLI. You're just generating your entity classes. They have a lot of getters and setters. And you were basically done, right? So it made it very easy to generate these kind of data containers, which unfortunately is the default for, or was the default for many of the MVC frameworks back then. So let me show you an example. It's PHP, don't worry. I think most of you probably can understand that. It's very easy to read. If you can't, or if you want to have another example, fetch me later. We have an order entity, right? It has 3 fields, a datetime field created at, a string status, and like a mutable collection items. I know it could be designed much better, but it should just get the point across right now. As I said, we have getters and setters, and we have a getItems method that returns a mutable collection to the outside. And of course, you have then an order service, that fetches the order from the DB, gets the status, does something, some validation, some processing, whatever, and sets the status to canceled and saves it back to the DB. I mean, this is even a little bit better than it was 5 years before 2012, because that would have been all in the controller, and the controller would have been the classic spaghetti code. But we're somewhere else. We're here. We evolved from spaghetti. Lasagna. Very tasty. But why are anemic models actually the driver for lasagna architecture, right? The problem is that it's just data. Like these entities with getters and setters, they don't have behavior. They're just data containers in the end. They're just representation of your database and the references, and the collections and everything. And all the logic, the business logic, the important part, is spread out across the services, right? And you start building a lot of these services, and you get this lasagna architecture, not only on the service side, but also on the entity side, right? So it's encapsulation done wrong. So let me just read it here, the text. When the classes that describe the model and the classes that perform operations on the model are separate, the services contain all the domain logic, while the domain objects themselves contain practically none. Right? So that was one of our initial mistakes. And you probably have seen this chart before. This is the classic blood, sweat, and tears over time chart. So here's the anemic model, right? So as I said, it's very easy to get started, right? So yeah, you get a head start, you can deliver a lot, but it really, really gets messy very, very fast. So in comparison, what I call the rich model. And we will see what that means a little bit later. But a lot of people will tell you this is the sweet spot, right? To change the strategy of how you deliver code. So it's not. The really sweet spot is actually here, right? You need to know in advance that something goes wrong and you want to be changing before you have that additional cost, right? You want to have that investment earlier. Unfortunately, I haven't seen a single organization that has done that like that. If you did that, then please talk to me and tell me how you did it, especially how you convinced management to do that. Because it's very, very hard to get that point across. So that's where we were. I mean, this arrow probably goes outside of the spectrum, somewhere through Oslo, maybe even into the Norwegian Sea somewhere. I don't know. It's very, very long. So that was the first failure pattern. The second one is weak boundaries. So when I talk about that, I mean, there's all the talk about modular monoliths right now, right? Who needs microservices? We can build modular monoliths. If you have weak boundaries in a modular monolith, I can assure you, I don't give it 2 years and it will become just a messy lump of something, but not a modular thing. So what is a weak boundary? Means sharing information among distant elements of the system, right? I mean, very low cohesion. If you share information like with very close elements, you have a high cohesion, that's fine. But if they are very distant, that's not fine anymore. So this is how it looked like, right? So we have a use case A, it might be cancel order, might be whatever, something important, some activity, some capability within your organization. And you have this order service, as I said, because we have this lasagna, right? We are talking only to the service layers, we're not talking to the model itself. And we get another service now, another use case. That's talking to the same service because, don't repeat yourself. We already have that order service. Why should that new use case use something else? Why should we duplicate it? There's no need. You can just reuse it. More and more use cases come. And these use cases are very distant, right? Remember that. I mean, they look very close on this slide, but I mean, if you look like inside the organization, one might be, a customer care agent doing something. The other might be, the customer on your page making some update to their order details or something, right? So very, very distant in terms of where in the organization these kind of changes are created. So this thing just grows, right? Because what happens is all of these use cases and distant elements, they have this slightly different requirements, right? They are not really the same. They look the same. They kind of, if you bend them a little bit, you can make them fit. But you have to add exceptions for each of that use cases. A lot of conditionals that are checking. If this is an order request from this customer service agent, then do something else than that, right? So it accumulates a lot, and something we call the God class symptom. It gets a lot of, well, I call it like a force, a physical force, so it's gravity, right? So the larger it gets, the higher gravity it has, the more changes it attracts. So this was like Jupiter, maybe. And of course, the order entity was growing as well because there were a lot of getters and setters now because we just added database column after database column after database column to also accommodate for these new use cases, right? Another thing about weak boundaries, and a mistake that we did, is exposing private entity collections to the outside. So an example, like a use case, there's an order repository, right? And the use case gets the order and it does some changes. Everything is fine. You know, there's a consistency guarantee. We have a transaction. We save it. It's all good. But now, use case B has an order item repository. You see that often, for example, in report building, right? We don't need the orders. We just need the status from the order items and stuff. Back then, we thought it was a great idea. Obviously, nowadays, most of the people know it's not. But back then, we thought it's a great idea. But it breaks the consistency boundary, right? Keeping this setup consistent is virtually impossible. Because use case A, you know, does not know about use case B, and there might be a concurrent request updating, you know, the order items without the order actually knowing about it because it's already in memory. And you start, you know, corrupting your system. So another problem, so this is a path, and this path has been paved by us developers, right? So we were doing things in a way, right? We had these anemic models, we had these services, we had these weak boundaries. But, you know, when we were growing and more developers joined the company, they were also taking that part because, you know, you see where the others are going and you follow down that path. You're not just going to go like through the woods alone, right? You follow the path that the others have paved for you. And I call this syndrome, that's how we do things here. The classic answer to, you know, juniors asking very uncomfortable questions. Because it now enters multiple positive feedback loops, right? And that's why I believe these different problems together accelerated themselves. So as an example, like, imagine it's very messy, developer's very fed up, you know, with the system. He already like talked to management, we need to change something. Oh, it's not gonna continue like that. And, you know, nothing happens, he leaves the company, right? A new developer is hired. He walks down the same path as the others because, I mean, that's how we do things here, right? But really, do you think that's a great idea? Yeah, it works, you know. We're generating money. Our system is successful, yeah? Works. So the problems get worse, right? Because we continue to work in that way, right? And so it doesn't get better. Gets worse. The developer wants to change something, talks to management, hey, we need to change something. I have this urgent feeling that something is going very wrong. And at some point, that developer leaves. Right? And that's a circle you have. I mean, we had that experience multiple times that the people were fed up with working in that messy system. And, you know, not having the possibility to really deliver value. I mean, us as developers, we want our company to be successful. We want to be part of that value delivery. If we cannot do that, we're going to become very, very unhappy, right? Also a major driver for burnout. I mean, if you listen to the keynote yesterday, I think, then you've heard about it. So a lot of people were also like, nah, cannot do that. I need a year break or something. So this was repeating all the time, right? And the other problems as well. So the service lasagna, it all got worse. State management was distributed everywhere. And I mean, at some point, the database just said no. So much contention, so much locking that was happening there. You can imagine if you have like, you know, customers, you know, your customer base grew by, your customer base grew by 1,000% or even more, also the strain on the system grew, and you were not able to scale up. Back then, it was not just, oh yeah, I have this Aurora cluster, I can just, replace the instance, give me like, I don't know, R16 extra large or whatever Amazon is having right now. So back then, that was not possible. We were on a, bare metal servers actually running our stuff. So it was not easy to just scale up. So that's a summary for the failure patterns, because, there was much, much more that I haven't talked about here, which is testing, for example, right? So if you have this lasagna architecture, testing and mocking becomes super, super hard. If you do it and you want to change it later, it's becoming very, very hard to change the tests as well. So you have an additional layer of things that you don't want to change. But I just have a little bit of time to talk about these things. So if you want to hear more stories, catch me later. Again, summary, lasagna, very hard to change because you have so many different places. If you want to implement a new use case, it's not like this single place, I just make the change. You have to remember like where it actually happens. State management, as I said, very, very hard. Contention, locking in the database. And the developers are very unhappy, quitting. And this cycle even made the problem worse. So it spun out of control very quickly, right? So what can we do about it? That was the question we asked ourselves. And there's this path everybody's going through, so we need a new path, right? We need to go through the woods. We need to create a new path. Not the old stuff. No. It's a no-go zone now. We need to go to the right, not straight ahead. So we came up with we didn't come up with the 5-step improvement process. The 5-step improvement process is now in retrospect, that we can call it like that. But that's what I want to talk about right now. So what is the 5-step improvement process? The first thing is identifying the most valuable components in your system. And when I say valuable, there's so many dimensions to it, what actually valuable means within your organization. It's like if you Google measure value, you will find a lot of different answers to that question. The second step is aligning the organization around the target picture you want to have, right? We will talk about why this is an important step a little bit later. The third step is not diving directly in after you have, created this future target picture, but rather understand where you currently are, analyze, measure, and not just, running a static code analyzer tool over your code base. Yes, you do that as well, but there's more to it than just that. So now you have an understanding of your current landscape, you have an idea about the future landscape, so you prioritize that by value. So right now you can actually pick the most valuable component to actually start this, or pick multiple components if you have multiple teams working on it. But you can start with one as an experiment. You can go full force. That depends on the organization, of course. For us, it was a single service that we picked. And you finish that migration, and you go back to step 4. And you go back to step 4 until there's not enough value in that list anymore, right? So at some point, you will say, I'm not sure if we should, migrate that service that's used 4 times a year by 3 people in the organization, but rather, should we rather get rid of that use case, because why should we keep it for these 4 people in the organization? So let's talk about these individual steps a little bit in more detail. Identifying the most valuable components. Well, it's about creating new capabilities, it's about merging capabilities, it's about splitting capabilities, it's about reassessing capabilities within the organization, right? So it is repainting the landscape of how your organization works. So step 1 is a very strategic high-level thing, and you will not be able to pull this off without the support from senior management or the C-level, right? You cannot just do that, decide this in your team and do it. That's not going to work. The whole organization needs to be behind that. And it needs to have support from the top as well. So one success pattern that we have seen that worked very well for us is Wadley Mapping. Who knows Wadley Mapping here in the audience? One? Okay, and I'm going to explain a little bit more detail. So this is the Wadley Mapping canvas. This is an example for inventory management. It doesn't matter like that you cannot read the stickies. It's important that we talk about the different areas. Wadley Mapping is a method that first tries to understand the different value streams in your organization, right? How are the different business capabilities, the business components, the business itself delivering value? What are the dependencies? So how are these value chains related? And then puts them on an evolutionary map. And what that map does, we'll talk about in a second as well. An important part as well is that you anchor the value streams on the user's needs, right? You don't do it on some organizational goals or something. That's when people talk about customer focus, that's where it's coming from, right? Because you want to base your value delivery on the actual needs of the customers. So anchoring them on the user's needs is very important, because it will transform the way you think more into, okay, what does the customer want? What does the customer need? And how can we make money with that, right? Instead of how can we make money and use the customer for this, right? It's a very, very tiny detail, but it changes the trajectory a little bit. No, not only a little bit, a lot. And then you have the value chain, number 5 in this canvas, where we have the user's needs and we have the different capabilities, and then we have activities that contribute to these capabilities. And these activities are, sometimes they are dependent, sometimes they are not. So you're building these value streams for all of the user's needs. You do that for the different areas in your organization. I mean, you can do that for the whole thing. You can then have separate sessions for individual, capabilities. So there is also a way to drill down and identify these value streams. But the important part is the map, right? So we place that in the map, and on the left you see it from invisible to visible, right? So the value chain starts at the user, what the user sees, and it goes down to something that the user is not seeing, right? So the user sees an e-commerce website where he can put in his orders or his profile page. This is what the customer sees. The customer does not see fraud detection algorithms in the background, right? That's stuff that the customer does not see. So it's very detached. It's important to actually think about this as well, because the further it's away from the customer, the more you can think about actually, building a platform out of these things. So this map on the x-axis has 4 sections. It's Genesis, custom, product and rental, and commodity and utility. So this is an evolutionary scale. So when I talk about evolution, in the genesis quadrant, you're doing something new, right? You're doing something that has never been done before. For example, in our case, the bus market was liberalized. Nobody has built this kind of system for the bus market before. Airlines, a lot. Yeah, there were a lot of airlines. But buses are not planes. Buses are also not trains. So you have a very specific segment of the market that nobody has actually built such an application before. So you are in the genesis quadrant here, right? You're doing something very, very new. A manned mission to Mars would also be in that quadrant, right? So you do something for the first time. It's novel. You don't have any knowledge about how things can be done. There is no reference point. You cannot just look up, in some magazine, like how did others do that? You need to decide the way forward. But that's on the business level, right? So in the custom quadrant, you've built something, and now your competitors are also building something, right? So they all built their own thing. So on the German market, for example, we had like a few competitors, 4 or 5. They all also had to build this kind of system, right? There was nothing on the market you could just, rent or buy an off-the-shelf product like an HR software, for example, or Oracle or accounting and things like that. There was nothing like that. So every single competitor in the market has to custom build their own thing, right? So that's the next step in the evolution. So what's product and rental? So one competitor or someone gets to the idea, wait, so there's actually a lot of people using this and custom building this, so I could make that a product, right? I could actually make that an off-the-shelf product for somebody else to actually buy it. So that would be the next step in the evolution, right? So you're building a product for others. It's the classic, I'm gonna sell shovels while you dig for gold. So that's the product and rental quadrant. And then the commodity and utility is, it's industrialized, it's commoditized. Like the example would be plugs, electricity plugs, right? So you see them everywhere. They're heavily standardized, right? So changing the standard of a plug in the country just like that is not possible, right? Imagine how many plugs you would have to change in order to change that standard. There's a lot of inertia, a lot of standardization, a lot of industrialization in that sector. But it goes forward, like these applications evolve. And they have velocity, right? So you can also estimate how fast or how slow are these different activities and capabilities moving on the x-axis. How fast are they going from custom to product? How fast is a competitor, going to come up with actually producing a product out of his custom-built software and being then the first in the market, right? So it's a market opportunity also. So this is a tool on a strategic level, right, to understand how you should prioritize your capabilities. So another success pattern, team topologies and domain-driven design. I'm a big fan of domain-driven design. Who here has applied domain-driven design in their organization? Oh yeah, quite a few. Nice. So this is a domain chart. So you have like core capabilities. You have supporting capabilities like marketing, for example, or core capability, which is delivering, bus rides to the customer, or a generic capability, which means, okay, you need to pay your employees their salary on time, right? Everybody needs to do that. There is not a single organization that says, well, there are some, but they're not going to exist very long. Right? And you place these also on this kind of map. But you now add the constraint of how many people do you actually have to work on this, right? So you have, let's say, 175 developers. How do you prioritize that? Because that's where the money is spent on IT development, right? So how many people do you attach to this kind of capability? How many people should work on this capability? What is your strategic decision? How should these teams interact? So these are all things that you can do on this level, right? So it's about thinking about how can we align the number on resources and people that we have that can work on this, on the different capabilities. Of course, in the core quadrant, you want to have like the best people working on it. You want probably have spent more than on generic and other capabilities. But again, it's a strategic decision, and it's a strategic tool to help you make this decision. Because becoming faster in the core quadrant gives you the highest return on investment, right? Because you will probably deliver value to the organization that will help it achieve its goals. So let's talk about realigning the organization, right? We have now a prioritized list of these capabilities. We have, switched the people around a bit and, have created this kind of understanding of how these things are working in our organization. But the current team structure is completely a different one, right? The current team structure is the one that, has evolved before. It's not just tech, it's also people. And we need to, find ways of how we can, make the people in our organization work in the ways that we need to do in the future, right? Carving this new path through the woods, not going down the old path, but going down to the right. So one success pattern that we did is the so-called InverseConvey maneuver. Who has heard about Conway's law? Quite a few. So what's Conway's law? Like, the organization has a structure with communication, people are talking to each other, there's teams that are interacting, and what Conway's law said, that, an organization that is structured in a certain way will produce a system that is somehow equally structured, right? So the quote from Melvin Conway is this: if you have 4 groups working on a compiler, you'll probably get a 4-pass compiler. If you have 3 teams, you probably get a 3-pass compiler. If you have 1 team, single pass, right? So that's the core essence of it. So let's look at what happened in our organization. It looked like that. System was shit, organization was shit. Because you have to think that system was built and there is a positive feedback loop about the system. If you think Conway's law a little bit further, it's not just a single law, it's a feedback loop. Because you're changing the system, you're changing also the communication structures in your system. And that, again, has an effect on the organization. And, it's a positive feedback loop. So what we did is, first get the organization into a new structure, right? A structure that we believe is following, the strategic thinking that we have applied before to understand what are the different activities, how should they communicate with each other, right? What you define is an organizational structure, right? How does our organization deliver value? How is it supposed to deliver value? So we realign. What we did was we had a 3-day event where we went to Bavaria somewhere in a hotel. And a lot of the product owners were, pitching for these new components, for these new systems that we wanted to build. And, they basically built little booths. It was like a job fair, basically, right? So you came there was this huge hall. And then there was a job fair with all these new things that you could join, right? And they had pitches, and it was very, very good. And then there were some rules, right? So this team needs to have at least 5 developers and 2 front-end people and stuff like that. So you knew, okay, that was the expectation. And then you could go around and see what you liked, what you didn't like, talk to the people who were already there, kind of, let the people, align themselves instead of telling them, you're going to be working there, you're going to be working there, you're going to be working with that guy you hate, but sorry, that's just how we decided it. So rather, we thought it's better to let the people realign themselves. It was a wager, right? Could have gone horribly wrong, but it kind of worked. Of course, there were some teams that nobody wanted to work in. Who wants to work in an accounting team? But then we hired new people. That was like, that's the signal that you get. Okay, nobody wants to work there. We need to hire someone who actually wants to work in this kind of team. Right? Imagine we just assigned someone. They were like, no, they would not have been motivated. So it's a signal for you as an organization. Okay, let's hire people that actually want to work on these kind of things. So we did this, and there's now a constant force being pushed into the system. But this force, is very weak. You cannot just do this and expect that 3 months later, your shitty legacy system magically, like a unicorn, transforms itself into a modular monolith, right? That's not going to happen. This is a very tiny force, but a constant force. So what we have now is a map, right? We have these new capabilities. We know who's going to work on that. We know which teams that have been forming. So we have this kind of map. This is a map of Europe in 1871. I'm not saying that politically it was the same thing in our organization, but you have this alignment now, right? And the teams know what they want to work on. They know what their responsibilities are in the future system. But now you have still the old system. So another thing that worked very well for us was explicit ownership transfer. It's about drawing new boundaries in the code. It's about drawing that map that we have come up with into the existing code. So how did we do it? So you have 2 modules now, right? So one module has a lot of code that is for itself, another module, and then we have these shared parts in between. And we have these teams now that are responsible for these modules. And what we did is we used a feature, I think GitLab and GitHub are providing that, which is a code owner's file. So you can put this file into your repository. You can add the people that are responsible for the subtree in which the file is there. So you could always say, okay, this is the shared part. These people are there. You could also say, these people were responsible for that code before. These are the people that are responsible now. They come in together because you also want the knowledge to be distributed, right? You don't just want to have the new people being responsible for a part of code and they have never worked with it. So you want to bring those people together. That's also what we did. So every time you made a change, every time you made a pull request, all the old owners were notified and the new owners were notified, and there was a discussion happening right away, right? How does this work? And then the old owners would say, nah, that's not right. You should think about it differently, like that. So that was very, very helpful, and it's a very, very cheap way to achieve that. So let's talk about measuring and analyzing. It's about identifying the low-hanging fruits. Yeah, this is a classic coupling graph from a static code analyzer. But I want to mention more than just that, right? So static code analysis is one part of it. So what is the cyclomatic complexity, right? What are the different numbers, for example, for coupling, efferent coupling, the number of module dependencies, how big is this thing, how many lines of code are in this module, right? So to get an understanding of one part of the migration complexity, and that's the current state of the code, right? So it's one part of the equation. The second part, and I think even much more important, is behavioral analysis. So what does behavioral analysis mean? It means how often is the code changing? Which things are changing together? Which things are changed by a single team? Which things are changed by multiple teams, right? This gives you an idea of, how the teams are working with the code. Not just in which state it is right now, but how teams are working with it. And it gives you a lot of insights. For example, it lets you understand parts of the code that are changed very often, that are shared between multiple teams, so you can mark them as a hotspot, right? Because there probably you will have a lot of contention. There you probably will have a lot of problems when you try to separate these places. So you can say there is a high migration complexity in that part of the system, right? And I put a link on the bottom. I will put the slides online so you can go through the slides and click the links and everything, so that's fine. It's Treating Your Code as a Crime Scene by Adam Thornhill. He also has Code Scene, like a platform that is offering that, that way of code analysis also to, development teams if they need it. But you can start very, very simple. There is a tool called Git Effort. It's in the Git Extras package if you use Linux or Mac, where you can just say Git Effort, you pass a time range, and it gives you like the amount of changes. You can also add the author. So there's easier ways of how you can get started than going straight to buying in a license for a platform or something like that. And the third number is risk. Is revenue generation affected? The scale of operations, right? Is it like a high throughput, low latency scenario? So what is the scale, what is the operational risk that we have there? So these three metrics together, you need to find your own weighted function of these three things for your organization to make sense, right? I'm not saying this is the function you should use it, because you, in your organization, need to decide what's important for you right now, right? So we can put it into this kind of quadrants, right? On the bottom right, you have the low-hanging fruits, and on the top left, you have the last toothpaste in the tube. So probably D will never make it into the migration. There's definitely not going to be enough value for the organization to tackle, a migration with that high of a complexity. Probably rather, well, let's just kill this or re-implement it or whatever, right? So don't touch this anymore. So let's get started, right? So we have done everything. We identified all the components, we aligned the organization, we measured and analyzed. Now we have this prioritized list, so let's get started. So what we did is applying collaborative discovery to build and redesign the APIs for the new components and for the new systems, right? Because you have new activities, change activities. As we said, there was newly created, somewhere, reassessed, merged, split. So there's a need for new APIs. There is a need for new models that can represent that. So in our case, we used event storming, which is a collaborative modeling tool that you can use to discover these kind of APIs and these kind of models. There's other methods as well. Domain storytelling comes to mind. Event modeling is also another thing that is there. For us, event storming worked very well because I've been to a training before and it just made sense for us to use that. But I don't want to put that on you find what's working for you, and try it out. Another success pattern that's really important, tracing use case entry points. And here, I cannot stress enough, you should instrumentize your application with some kind of observability platform or open telemetry or something like that. Because what it does, it gives you the ability to trace any request in the system that goes through a certain module to the actual queries it does on the database, right? And if you have that information, you can actually get all these entry points together that are working with the database tables that you deem necessary for a certain, use case that you want to newly implement. So you can get this list of entry points from the observability platform, right? Because we need to know where to start. We need to know like where in this messy system is actually the start for us to go in. So most of the data, most of the observability tooling right now offers that. With JDBC, you normally have normal integration, standard integration that tells you exactly like which of the requests is doing which queries, right? So you can start building a list. So another success pattern is rich models. I'm going to quickly go through. So instead of spreading this logic to the service layer, we're now putting this logic into the actual entities, right? So that's all it is. That's what a rich model does, is moving the behavior back into the entities, moving the behavior back into the models, right? Instead of doing this cancel check somewhere outside, we have it inside the entity. And then the handlers are looking like that, and you normally don't need to change them, which is getting the repository and saving it. And only then are you actually starting to strangle. So the strangler pattern, at least for us, is actually not called strangler pattern. It's something else, probably the FiveStep improvement pattern, but not the strangler pattern. But let me go quickly through, because now it gets very easy when you're at that point, right? So you have a facade that is now following your newly discovered APIs, and in our case, we use the transactional outbox pattern to implement it and reuse the transaction boundary that was already within the system. And we could generate events from these existing use cases. And from these events, we could, consume these events in a new service and keep it updated. So we were in sync with the legacy system. Of course, you have to repeat that for all of the entry points, right? So it's not, I say it's easy, but it's a lot of work. Don't confuse these two things, right? When I say, because you have all the information, you know where to go, but it's still a lot of work. So now what you do when you have a sync between them, you reverse the direction, right? So instead of talking to the legacy system first, you talk to the remote client. There's other intermediate steps that you can take. For example, having a feature flag that calls both of these things, compares the responses, and sees like, are they behaving the same? Are they behaving differently? If you have a higher risk, you can add more. But since you added this facade with a new interface in front of it, you can have any abstractions, any implementation behind it. Feature flags, whatever. You're very free to add things behind these facades. And then you use the new service. The service puts it onto your queue. You have this order event. And now the legacy system is syncing the order event and gets updated. And this will run for quite some time, don't get me wrong. You have probably BI, reporting, analysis inside your organization that will depend on data from the legacy system for quite some time. So this synchronization is not something that will just, it's 2 weeks and then we remove it. So there's probably, there needs to be a process defined of how can we get the reporting up to the new structures. It's also not an easy task. So expect that to be there for a little bit longer. Well, you're done. You do now pick the next thing. You go back to step 4 and you repeat until you believe it's not valuable anymore. So to summarize, we start with a strategic, assessment and define a new map for our organization, for our capabilities. We realign the organization around this new target picture. We measure and understand the current situation that we're in right now to make appropriate decisions. Then we design our new APIs that we have discovered in the sessions before. We leverage the observability platforms to understand, okay, how are these use cases coming together? And then we tackle each of these points with a Strangler facade implementation. Sounds simple, right? So that's it. I think an hour is gone. I could talk a lot more about it, but I had to make to cut it short for some. So if you want to know more, grab me later. Thank you very much.